There's another property that we use to help us solve linear equations, and that property is the multiplication property of equality. It's very similar to the addition property of equality. If I start with two things that are equal, I go back to my stacks of money. If I double the amount of money on the left side, my stacks of money are no longer equal. To keep their values equal, I have to do that same thing. I need to double my stacks of money on the right-hand side. Division can always be rewritten as multiplication. So this rule applies to division as well. If I divide my stack of money in half, to keep it equal, I have to get rid of half of my money and the other stack to keep it equal. This property, like the other, means whatever you multiply or divide one side of the equation by, you must multiply or divide the other's equation as well. You're going to see that common theme as you learn more and more about solving equations. Whatever you do to one side, you got to do to the other side. Let's solve negative 81 equals 27x. My goal is to have a variable equal to a number. The coefficient on the variable needs to be positive 1. Currently, the coefficient on my variable term is 27. I want to get rid of that 27. The operation between the 27 and x is multiplication. I'm going to perform the opposite operation to remove that 27. I'm going to divide by 27. And think about that. 27 divided by 27 gives us 1. It essentially eliminates the coefficient that we don't want. We want the coefficient on x to be 1. To keep it legal, whatever I do to one side, I got to do to the other side. Negative 81 divided by 27 gives me negative 3. So I'm going to rewrite that a little bit cleaner. Negative 3 equals x. We can check these answers just as we did the others. We're going to simply plug our answer into our original equation. Is negative 81, is that equal to 27 times negative 3? Cleaning up the right-hand side, we see that we do get a true statement of negative 81 equal to negative 81. In our next example, c divided by negative 4 equals 7. C is not all by itself with a coefficient of 1 because we have this division of negative 4. To eliminate the division by negative 4, we're going to perform the opposite operation, and we are going to multiply by negative 4. We know when multiplying fractions that we can simplify first. We can cross-cancel any numerator with any denominator. So those negative 4s cancel out for us, leaving us with just 1c. To keep it legal, whatever we do to one side, we got to do to the other side. 7 times negative 4, negative 28. We end up with c equals negative 28. To solve 3y equals negative 18, I need to eliminate that multiplication by 3 in front of the y. We're going to perform the opposite operation. We are going to divide by 3, and whatever we do to one side, we make sure to do to the other side. 3 divided by 3 gives me 1y. and negative 18 divided by 3, negative 6. Y equals negative 6. Our last example is division again. X is being divided by negative 9. To get x all by itself, I need to eliminate that division. I'm going to perform the opposite operation. I'm going to multiply by negative 9. Those negative 9s are going to cancel out, leaving me with just a positive 1x on the right-hand side. To keep it legal, we got to do the exact same operation on the left-hand side. I even put that in parentheses to make sure that I actually multiply. Negative 9 times negative 5 gives me a positive 45. X equals 45. I'm going to show you how to check this one. We haven't seen one with division yet. Checking is the same way. We simply plug our answer, our solution, into our original equation and make sure that we get a true statement. So is negative 5 equal to 45 divided by negative 9? Cleaning up that right-hand side, we see that we do get a true statement of negative 5 equal to negative 5.